Welcome to lesson number 2, and this we're gonna be talking about gradients and everything about gradients. Okay, so firstly, what is a gradient? Gradient is basically it's the slope of a graph. Okay, and there's 4 different types of gradients we're gonna be looking at in maths methods. So firstly, this might be a graph. Okay, what sort of gradient is this? Well, this is gonna be a positive gradient. Positive. Alright, so what does that mean? If you're going from left to right, if you're reading a left to right and you're going uphill, that's a positive gradient, okay? So even something very flat graph, a very flat graph like this, it's still going uphill, so that's also positive. So obviously we have a positive gradient, then we're definitely going to have a negative gradient. It's going to go down. So this is a negative gradient, alright? So now, this gradient is negative because if you're reading it from left to right, it's going to go downhill, right? Downhill, that's what makes it negative. Next, what if you have a horizontal line? So if you have a horizontal line like so, right, what sort of gradient would that have? That would have a 0 gradient, so its gradient is 0, you can say. Right, and lastly, we have a vertical line, okay? So let's say a vertical line like this, okay? This would have actually a gradient of undefined. All right, you might be asking, why is this undefined? Why is this 0? Why is this positive, negative? Okay, I'm gonna tell you that after we learn how to calculate gradient. Right, so we're going to learn how to calculate gradient between 2 coordinates first, right? So we all know that gradient m is a symbol for gradient, is going to be rise over run. So rise is going to be pretty much, again, I'm going to break these 2 coordinates into a right angle triangle, right? Rise is going to be how far up the graph goes, pretty much the height of the triangle, so how far the height is increased, and run is how far to the right it goes, in other words, the width of the triangle. So we know that height m is equal to rise over run. It's a slope. So how do you calculate the rise? Well, we actually did this similar process when we find distance in the previous lesson. So this is going to be y2 is the height of the coordinate b is y2. Height of coordinate a is y1. So rise is obviously y2 minus y1. And run, for similar reasons, is x2 minus x1. So rise, if its rise is y2 minus y1, then gradient is y2 minus y1 over x2 minus x1, rise over run, right? So this is pretty much the equation of the graph. So the equation of the gradient. So let's go back and talk about why is this positive, why is this negative, and so on. Let's pick 2 random points, doesn't matter where. And if you draw a right angle triangle, what is the rise? Well, we know that the rise is going to be a positive rise, right? Because it's increased, it's going up. And the run is always positive because it's going from left to right. Run is also positive. So we know that gradient is equal to rise over run. Okay, so rise over run, which is, if rise is positive and run is positive, overall you're going to have positive number. So that's why this uphill sort of line is a positive gradient. Now let's do a negative gradient. So again, I'm going to pick 2 random points. Doesn't matter where they are because the gradient is the same all the way throughout. So again, 2 random points. Now what do you notice, right? So run is still positive because it's going from left to right. We're going this way for the run. But you can see the rise here is going down. So we have a negative rise this time. So gradient m is equal, again, remember, rise over run. Now we have rise is actually negative this time. So negative rise over positive run. So what's negative divided by a positive number? It's overall negative number. All right, that's it. So now let's investigate horizontal and vertical lines. Well, this is a bit weird. Okay, can't really draw a diagram for this. Okay, so what is the rise of this graph? Is it rising at all? No, because it's always horizontal, right? So the rise is actually 0. So rise is 0. What's the run? Well, technically, we can kind of say run is infinity, maybe. But it doesn't really matter because 0 divided by anything is actually overall 0. Right, so that's why this graph has a 0 gradient. All right, lastly, so it's a vertical gradient. Again, it's a bit of a special case. M is rise over run. Now, what is the rise for this case? Technically, it's infinity. Maybe. We don't really know. Okay. And what about run? Now, run, it's not moving left or right anywhere. So run is actually 0. And now we know that you cannot divide any number. Doesn't matter what it is. You cannot divide by 0. If you try divide by 0, even in your calculator, have a go, it will give you a value of undefined. Okay. So this is why there are 4 types of gradients. You can have positive, negative, 0, and undefined. 4 different kinds of gradients. All right. So now let's start using our equation. y2 minus y1 and x2 minus x1. Let's use that equation to to do a question. So find the gradient between part A is 4, 10, and 5 and 17. Again, you can label if you want. So this is x1, y1, x2, y2. It's really simple. Gradient is going to be y2 minus y1, so 17 minus 10 over 5 minus 4. So 17 minus 10 is 7, 5 over minus 4 is 1. So this gradient is just 7. Really simple. Let's try a slightly difficult one, more harder one. These are pretty easy though, no, they're not that hard. So what's y2? I want to label this time. So y2 is 5, y1 is 4, so 5 minus 4. And x2 is 25, x1 is 16. So 5 minus 4 is 1, 25 minus 16 is 9. So gradient is a fraction, 1 over 9. This is still a positive number, it's positive 1 over 9. So the gradient is still a positive gradient, okay? Just because it's a fraction doesn't mean it's any different, all right? So that's it, that's my walkthrough. Why don't you guys have a go at doing these questions by yourself? Pause the video. All right, I'll now give you the answers. In fact, I'm actually going to do all of these with you guys because it's fairly simple. I'm going to say gradient, again, for the first question is y2, negative 3, minus y1, 4, over x2, which is 4, minus, now look, we have noticed we're minusing a negative number, so you have to put it in brackets, minus negative 3. Okay, so what are you left with is negative 3 minus 4 is negative 7. 4 minus minus 3 is 4 plus 3, which is 7. So negative 7 divided by 7 is negative 1, which is the answer. All right, this next one's a bit different. It's a bit weird. Let's see. M, 7b is y2, so it's y2. I'll actually label it for you guys because it's a little tricky. I'll label it x1, y1, x2, y2. All right, so obviously y2 minus y1, 7b minus 3b, 3b over 5b minus 4b. Okay, so is that it? Is that the answer? No, we can collect the like terms. 7b minus 3b is 4b. 5b minus 4b is just 1b, you can say. Now, because we have b on the top and bottom of fraction, you can cancel it out. So in other words, you have 4 over 1. So the gradient is 4. That's it. All right. So next one, last one we're going to do together. I'll need a bit of space for this. So I'm going to copy it down. All right. So this question. 6a, 5a, 6b, and 5b. So again, I'll label x1, y1, x2, y2. Now we'll plug it into the formula. So we have y2 minus y1, so m is equal to 5b is y2 minus y1 is 5a over 6b minus 6a. All right, so this one's a little bit more interesting. So is that it? Because we cannot really collect, these are not like terms, so we cannot add them together. But what we can do here is factorize the numbers out. Okay, so remember, we haven't done factorization yet, but you should remember from last year, we have to take 5, because 5 is a common factor in both, we can factorize it out. So we can say 5 is b minus a. All right, if you guys want, make sure you leave a request, or I'll upload a factorization lesson quickly. So if you guys want, I'll definitely make that one for you if you can't do this. And make sure you watch that if you don't understand this. So, and the bottom also, you can factorize. You can, what's a common factor is 6. If you take 6 out, you're gonna have b minus a as well. And look at that, because it's multiplying, these are multiplying, we can cancel out b minus a from top and bottom, just like how we cancel out b over here in this previous question. We cancel out the b. So we can cancel out b minus a, and all you're left with is 5 over 6 as your answer. Okay, I hope you understand. So last question for this topic, for this lesson, is this. So straight line has a gradient of -2 and passes through -2 and 5 and 4 and a. All right, so it's similar to how we did those distance, speed, and time questions, not distance, speed, and time, distance and midpoint questions last lesson. So I'll show you how to do this, okay? So first, ignore this -2 and just find the gradient between these 2 points, okay? Gradient is going to be m is equal to y2, which is a, minus y1, which is -2. So make sure you put that in brackets. Oh, it's not -2, so it's 5. So a minus 5. A minus 5. So then you put that divided by 4, which is x2 minus x1 is -2. All right, so this is your gradient. Let's simplify as much as possible. So you have a minus 5 is over 4 minus -2 is 6. So 4 plus 2. So now this is our gradient between these 2 coordinates. Now what's the question saying? The question is saying that this gradient has to be equal to -2. Right, this has to be equal to -2. So now we have an equation, then we just solve it. So you have a minus 5 is equal to -12. A is equal to -12 plus 5 a is equal to -7, and that's your final answer. Alright, so that's pretty much a quick walkthrough with gradient. We're going to be working a lot more with gradients, especially in later chapters with calculus and stuff. That's pretty much all about gradient, but this is just like a quick little intro to the topic. So I hope you understood. I'll see you soon.